5G Wi-Fi. This is all about the generations of Wi-Fi. We are on the 5th generation of Wi-Fi. The prior 4 being A2.11, B, A, G, and those were the 4, and now we are on the 5th generation of Wi-Fi, which is AC. So when we talk to the consumer, and explain this is 11AC, A2.11AC, the challenge is 11AC is only about 5 gigahertz frequency band. But the consumer wants to have Wi-Fi as an experience that not only works with today's generation of Wi-Fi, but also with all prior generations of Wi-Fi, legacy Wi-Fi. So to communicate to the consumer what a consumer experience is going to be around this new technology of Wi-Fi, or new Wi-Fi specification, 802.11ac, we are calling it 5th generation of Wi-Fi, 5G Wi-Fi. 5G Wi-Fi is about a standard experience that a consumer would come to want with 11AC and all the legacy modes of Wi-Fi that the consumer has in their homes, in their lives on a day-to-day basis, used today and yesterday. 5G Wi-Fi is largely based on the principles of improving the link budget, the throughput between two connected devices, not only at a shorter distance but also at the edge of the home. There are a few things that have been significantly improved in 5G Wi-Fi or 11AC specification. The first one is the channel width. It's gone up from 40 megahertz to 80 megahertz, so double the channel width. That improves the amount of things that you can do in the whole channel, basically, because you now got wider channels to work with than what you had in 11N. So you can pack twice the amount of data, technically. The other big thing is the modulation scheme has gone to higher modulation from 64 QAM to 256 QAM. Now that also furthers the improvement on the link budget, improves the throughput. And the third big thing, which everybody's kind of done in PCs in the prior generation of Wi-Fi, and it's not standard specified, and it's not kind of followed through from an interoperability point of view between two different devices, is transmit beamforming, right? And so beamforming is now a specified algorithm, and the way to do it is in the 11AC spec, and so everybody follows the spec. It improves the interoperability and makes it more real when you get to realize beamforming benefits, which is improving range dramatically by almost, on an average in situations it can double the range over what it was in 11N, right? And you can see, if you look at this screen, inside there we have Broadcom's first 11AC device, which is 3x3 11AC, but it's a 5G Wi-Fi device that also interoperates with legacy products. They are on Wi-Fi standard-based implementations that are there in the marketplace, which could be in 2.4 gigahertz, it could be 11B, 11G, 11N. Those chips, when put to work in that environment, basically can yield 1 gigabit per second connectivity on the link, basically. And today there is not a single Wi-Fi device in the marketplace that can get us 1 gigabit per second in a 3x3 form. And this 11AC implementation that we have now running at Broadcom, this 5 gig of implementation, is getting us 1 gigabit per second Wi-Fi. So these are the big improvements that you see in 5G Wi-Fi and 11AC, that now not only on spec, not only on paper, but now you can see them in a Broadcom implementation right here. Broadcom's coming out with a solution that is going to be made available, we believe, 6 to 9 months ahead of the rest of the marketplace. So giving our customers who are going to bring the experience and the solutions to the marketplace a head start. That is what Broadcom's doing, right? We invested in this next generation Wi-Fi much ahead of everybody else, right? We are bringing this experience to the end consumer, ultimately through our customers, much ahead of everybody else. So probably about 6 to 9 months ahead of everybody. I don't know our competitors' plans or everybody else's plans, but today it seems, based on everything that we pulse in the marketplace, that Broadcom's got a nice lead in this marketplace with its 11AC implementation. And so I can't comment about our competitors because I haven't seen anything in the marketplace. It is a little bit, it is not a secret tent, so I'll describe it for you, right? This is a shielded environment for Wi-Fi, so that we minimize the interference coming in over here versus outside. As you know, at CES, there's a lot of Wi-Fi access points. People have a lot of Wi-Fi devices over there, and so there's going to be a lot of interference. And so here we have a setup where Broadcom's first 11AC device, it's called BCM4360 base implementation, connected to another BCM4360 11AC implementation, and these two devices are talking to each other over a Wi-Fi link, and it's yielding greater than 1 gigabit per second connectivity or throughput, right? So the link budget dramatically is increased. Broadcom's also got a router implementation right here that is going to be available in commercial form, that would be seen in production sometime second half of this year, right? These routers will go in the home applications, basically, where average consumer would be able to buy these routers from a retail store. That would be an AC supporting concurrent dual band, supporting AC as well as legacy 2.4 gig implementations in your router that you would take in your home. With today's Wi-Fi is there's so many devices in the 2.4 gig band that Wi-Fi is kind of tripping over itself largely, because I think there's only so much from a medium point of view that you have available to yourself, number one. Number two, you've got too many devices trying to share the same medium, and so they're kind of sharing the bandwidth and ultimately not helping the experience, because you get less of a bandwidth per device. In 5 gigahertz frequency band, there's a lot more channels available in 2.4 gig, number one. Number two, 5 gig in itself by design is not overlapping. The channels are not overlapping versus 2.4 gig where they can be overlapping. So it's equivalent of somebody driving on a freeway, not sticking to their lane, but driving in the middle of the lane, so that way they occupy two lanes. That's what happens in the 2.4 gig. In 5 gig, you have to stick to your lane. You can be driving in the middle of the lane, and so you have to stick to your lane, number one. Number two, you have a lot more lanes on the 5 gigahertz freeway versus the 2.4 gig freeway, where you have 3. Over here you have about 20 lanes. And so these are some of the things that are going to improve the experience on a going forward basis with 11AC, combined with the benefits of 11AC as we discussed earlier, which is wider channel, wider lane, more lanes, wider lane, and then faster modulation. That means you can pack a lot more in a shorter amount of time versus what you could do in legacy Wi-Fi. So now if you are on the freeway, you're on a wider channel or a wider lane, you're packing a lot more. That means you're going much faster and you're clearing up your lane much faster. So now the chances of interference have come down dramatically in the 5 gigahertz band with 11AC versus what we had in the 2.4 gig band. What 11AC does in the 5th generation of Wi-Fi, keeping in mind the compatibility and the backwards looking legacy mode that's needed for the experience to be there for the end consumer. It talks about a lot of things. It's got white papers, it's got videos, it's got blogs discussing real life issues, it's got application level implementation benefits. For example, how 5G Wi-Fi helps a cellular handset experience, how 5G Wi-Fi helps the video streaming experience in the home, how 5G Wi-Fi helps fast synchronization experience, right, that you would otherwise have to rely on your USB cable or Ethernet, right, to sync between the two devices. So that is all what this website talks about. It's also got videos, and you can see the video that we've put together. It's kind of bringing out the experience of the day-to-day life. Here in this video, it's an aspirational video about the 5th generation of Wi-Fi. What it shows is a mom has taken pictures on her handset. Now she walks into the home, right, or she wants to take the pictures from her laptop into her handset. She can quickly swipe, using Wi-Fi Direct technology. With Wi-Fi wireless display, she would be able to put those pictures or the video that's on the laptop that she's watching with her son onto the big screen. Those are the experiences that 5th generation of Wi-Fi aspires to bring to the end consumer, basically. This is 5G Wi-Fi, and it's all available on this 5GWifi.org website.